In this video, we will learn how to name alcohol molecules using both the Iupac terminology, that's International Union of Pure and Applied Chemistry, as well as determining the so-called common names for alcohols. Because in many cases, simple alcohols very often, even on consumer packaging, go by their common names rather than their so-called Iupac name. We'll begin here with the Iupac system of nomenclature. Let's dive in and take a look at the Iupac rules for alcohols. The information based here in this video derives directly from video 310 and 311, where we looked at the Iupac rules for naming alkanes and haloalkanes. We're going to see many parallels here in terms of how you go about finding the names of these molecules. And if you're rusty on Iupac nomenclature in general, definitely go back and revisit video number 310. To apply that information specifically toward alcohols, the first thing that we need to do is find the longest carbon chain, which was something that we did back when we were naming alkanes as well. But here, when you have an alcohol group, we have to find the longest carbon chain that contains the carbon that is part of the alcohol group. And we'll start numbering at the end closest to that carbon that has the alcohol group bonded to it. I'll go ahead and write that down for us. We're going to number the longest carbon chain that has that carbon that's directly bonded to the OH group in that longest carbon chain. We'll number from the end of the chain that is closer to that COH group. Second thing we will do is to determine the parent name of this molecule. The parent name is going to have the suffix OL, where we would take the alkane name, such as methane, and if there's an alcohol group present in the molecule, we rename methane to methanol with an OL suffix, designating that there is an alcohol group. So let's go ahead and write that second rule down, which is that we will remove the E from the end of the alkane name. And the alkane would be if there was no hydroxy group in the molecule whatsoever. Remove the E from that alkane name and add the suffix OL instead. So remove the E from the alkane name and replace it with OL for alcohol. For example, if we had a 5-carbon alkane, it would be named pentane. If we had a 5-carbon alcohol, it would be referred to as pentanol. So pentane, which would refer to an alkane, becomes, in the case of an alcohol group present somewhere in that 5-carbon chain, would be renamed as pentanol. And that is not all that we need to be concerned about there, because in the case of pentanol, where you have a 5-carbon chain, 1, 2, 3, 4, 5, there are multiple positions along that chain where the alcohol group could be located. For example, the two scenarios that I show here, one of which has the branch at carbon number 2 of the chain, one of which has the branch to the alcohol at carbon number 3 of the chain. And therefore, to fully specify the structure of an alcohol molecule, rather than just saying pentanol, which could refer to either of these, to be unambiguous, we have to designate the location of the alcohol group as well. So once we come up with the parent name, plus we need to indicate a number to designate where the hydroxy group, OH group, branches off of the parent chain. So we're going to number to indicate the location of the OH group on the parent chain, numbering from the end closer to where that alcohol group is, per what we saw in step 1 of nomenclature. Then finally, completely analogously to naming alkanes and haloalkanes and all the other types of molecules we've looked at so far, we need to name and number the branches on the chain. Those are the so-called alkyl groups, such as methyl, isopropyl, tert-butyl, etc., etc. We list those in alphabetical order as prefixes in the overall name for the molecule. So third step, name and number the branches, which we also have called in the past substituents, on that longest carbon chain, i.e. naming the alkyl groups. List those as prefixes in the name in alphabetical order. So I'm going to put and alpha, running a little low on room there, to indicate that we're going to put them in alphabetical order. Let's go ahead and apply these rules toward determining the name of a couple of example problems now. For convenience, I've kept my Iupac rules there in the upper left-hand corner for us. I'm going to draw an example structure here that we will work with for purposes of providing the Iupac name for this molecule. So let's go ahead and take a look at this structure and try to determine the Iupac name for it. First thing, number the longest carbon chain that contains the carbon that has the OH group. And we're going to number that from the end closer to where that COH group is located. I'm getting out my highlighter marker to help us identify that. To identify the longest carbon chain, starting from the end closer to the hydroxy group, we have this hydroxy group to anchor us, so I'm expecting the longest carbon chain is going to start somewhere over here. In fact, since this is a methyl group and this is a methyl group and they're both attached to the same carbon here, you could start at either of these two methyl groups as carbon number 1 of the chain. You're going to come up with the same name one way or the other. So pick one of those two to start your longest carbon chain. Tracing through, mapping out the longest path, I get to right here, and at this point I say to myself, which direction is going to take me on a longer route? Coming this way we get 2 more carbons out of the chain. Coming this way we get 1, 2, 3. So 1, 2, 3 is going to be the correct way to go there because that is our longer path. So we come through here, here, and here. That maps out our longest carbon chain. From there, we number our longest carbon chain, continuing to follow step 1 of our nomenclature rules there in the upper left corner, numbering from the end closer to where the COH group is. So that means we need to start numbering from this end. 1, 2, 3, 4, 5, 6, and 7. A 7-carbon chain we refer to, if it's just an alkane chain, as heptane. Heptane designates 7 carbons, as we learned back in video 310 and in our handout materials with that video. So the parent name would be heptane if it did not have the alcohol group, but due to the fact that we need the name to also designate that there's this alcohol group present, we would refer to the structure instead as 2 alcohol. And number 2 there because it's carbon number 2 of the chain where the alcohol group branches off of the parent chain. There is a synonym for 2-heptanol that you would also be welcome to use, which is heptan-2-OL, putting the number 2 as close to the designation of the functional group as possible to perhaps reduce ambiguity about where number 2 is branching off. So now with this in place, we have specified the location of the parent chain, including the alcohol group that comes off of that parent chain. Now our next task in our workflow is to go ahead and determine the names and numbers of the branches on the chain, and we'll list those prefixes in alphabetical order here in front of the parent name. Let's go ahead and give that a try. Finding my branches, it's everything that we haven't already highlighted as part of the parent group. So I've highlighted in red here, here, and here, the 3 branches that we have coming off of the parent chain. We need to determine the name of those 3 branches that are coming off of the parent chain. And I would specify this as 2 different methyl groups. Methyl group here, because it's a 1-carbon chain. Methyl group here, another 1-carbon branch. And ethyl group here, because there's a carbon here and a carbon here, where I put the red dots. So that would make that an ethyl group. And from there, we need to specify where those are located along the parent. So our methyl group at the left is at position number 2 of the chain, is where it branches off. So we would call that 2-methyl. Our ethyl group is at position 4, so we would call that 4-ethyl. 4-ethyl to be specific. And then at position number 5 of our chain is where the methyl branch comes off, so we could call that 5-methyl. Now, when we have multiple groups that are identical, such as 2-methyl and 5-methyl, we lump those together in the prefix, and we call that a dimethyl group. More specifically, we call it 2,5-dimethyl group. Then we list the ethyl group as well, and we do this all in alphabetical order. Ethyl comes before methyl in the alphabet. And so ethyl is going to come first in the prefixes here, listing it as 4-ethyl, and then followed by 2, 5 dimethyl, because there are 2 methyl groups on that chain, not just one. And remembering that when we alphabetize, this is a good example of how we alphabetize based on the name that identifies the group rather than how many of it there are. So this is why ethyl comes before dimethyl, even though D comes first in the alphabet, is because we alphabetize based on the name that identifies the group, ethyl versus methyl, rather than something that specifies how many of it there are, such as the term di, tri, or tetra. So in total, this would give us our complete Iupac name for this molecule, as I'm circling and highlighting here in green. Let's try another example problem before we conclude our discussion of Iupac rules for alcohols. I'm going to shrink down further some of this existing knowledge that we have to give us a little more elbow room to work. Let's determine the Iupac name for the alcohol molecule that I show here in the lower left-hand corner of the screen. What you will notice that distinguishes this molecule from our earlier example straight away is that the carbon atoms are in a ring rather than in a chain. This ring, where we have a hexagon shape, indicates that all the carbons are latched together, not into a linear chain, but instead they form a ring with 6 carbon atoms represented by the bends in the line as we come around the structure there. To name cyclomolecules that are not aromatic, we know this is not aromatic because there's not the single bond, double bond pattern inside the ring, we refer to these as cyclocompounds. So into the parent name, rather than just calling a 6-membered ring hexane, we would call it cyclohexane. And indeed, for this compound, in order to name cyclic alkanes and then cyclic alcohols, we find the ring and the branch coming off of it that gives it its parent name. That is our alcohol branch. So we would call this parent name cyclo, for the fact that there's a ring, hex, and OL, the OL there indicating there is an alcohol group coming off of the ring. You do not need to specify the numerical location of the alcohol group. It is defined as being at position number 1 because rather than finding the longest chain and starting at the end closer to the alcohol group, instead, we always start numbering the ring where that group that determines the parent name is located. So number 1 would be where the alcohol group is located of that ring. And then we take the shortest path around to get to the next branch. So we're going to go around the ring this way, 1, 2, 3, 4, 5, 6, rather than numbering in the other orientation, going this way to get to position 2, 3, 4, and 5, because this is going to take us the shorter route to get to the other branch that is on the ring. That's the branch right here at carbon number 3. And then to determine the full Iupac name for this molecule, what we will do is specify the name and location of the branch, much like we did with acyclic molecules. So we'd call this 3-methyl cyclohexanol as the complete and full Iupac name for this cyclic molecule. So to recap, when we are naming cyclic alkanes and cyclic alcohols, what you need to remember is that to designate the structure is a cyclic molecule where the atoms are locked into a ring, we just attach the term cyclo before the name that would designate how many carbon atoms are in the ring, where typically we have in rings 5 carbons or 6 carbons, meaning the parent name is cyclopentane or cyclohexane. In the case of this, since there's an alcohol group as well, we have to tag on the OL suffix to designate that it is an alcohol. No number is necessary to indicate where the alcohol group is located. It's implied that the alcohol group must be at carbon number 1 of the ring because the alcohol takes priority in determining how to number the ring, just like it took priority in determining how to number a chain as well. Then we proceed around the ring in the shortest possible direction to get to the next branch. That took us this way, as my laser pointer is showing in this molecule, to get us to the branch at position number 3. That was a methyl branch, so we specify as 3-methyl. Run that into the parent name cyclohexanol, and we are good to go. In addition to being knowledgeable and able to interpret the Iupac names for alcohols, we also commonly refer to alcohols by their so-called common names. The common names of alcohols follow the general template of taking the alkyl group name that would correspond to a branch and adding the term alcohol after it. So the way that we name these commonly is name the alkyl group, and after naming the alkyl group, such as ethyl, methyl, isopropyl, tert-butyl, tag the term alcohol on to the end of that name as a separate word. Let's look at an example of this. An example problem we could represent as this structure here, which if we were determining the Iupac name for that molecule, we would follow our Iupac rules, finding the longest carbon chain, starting at the end closer to the alkyl group, so 3 carbons in our longest carbon chain, 1, 2, 3. That would give us a parent name of 2-propanol, since there are 3 carbons in that longest carbon chain, or propan-2-ol if we preferred. And that would be the entirety of the Iupac name for that compound, because other than this 3-carbon chain that has the hydroxy group on it, there's no other branches to account for. So our Iupac name would be that in its entirety. On the other hand, the common name for this molecule, when we think about the common name, we're going to apply that rule at the top. They name the alkyl group and add the term alcohol to it. The common name for this is actually much more generally applied than the 2-propanol Iupac name. And that common name that would correspond to this molecule is going to be isopropyl alcohol. And most brands of sterilizing alcohol that you have in your medicine cabinet, in fact, will have the term isopropyl alcohol written on them, not 2-propanol. If you look at the fine print, somewhere on the bottle it will likely say 2-propanol, the Iupac name, but the common way to refer to this structure is just as isopropyl alcohol. And we call it isopropyl alcohol because this 3-carbon group right here that I'm highlighting in yellow, if we think of that as a branch off of another chain, this is referred to as an isopropyl group. We learned that back in video 310 when we were learning about different alkyl branches that come off of parent chains. So here, we're just treating this like it is a branch that comes off of the oxygen being the so-called parent. That's the common jargon and common designation for determining the names of these using common systems of nomenclature. Let's do another example here. In this example, we will have this structure that we're asked to determine both the Iupac name for and the common name. So I'm going to put a space here for Iupac, and I'm going to put, in a different color here, a space for the common name of this molecule. How do we come up with the name for that? Well, Iupac, find the longest carbon chain. Longest carbon chain here is 3 carbons, 1, 2, 3. That intersection there is carbon number 2 of the chain. We could have also come through this way 1, 2, 3, or this way 1, 2, 3. Doesn't matter, due to the symmetry in the molecule, you're going to come up with the same name one way or the other. Number from the end starting closest to the alcohol group. In this case, due to the symmetry, you could have started at the right-hand end as well. You'll come up with the same name one way or the other. And we are going to then specify this structure with an Iupac name of 2-propanol. So Iupac name of 2-propanol as the parent. But there's more because we haven't yet accounted for the fact that there's a branch coming off here at position number 2. And that branch coming off at position 2 is a 2-methyl group because that is a 1-carbon chain coming off there. So our Iupac name here would be 2-methyl 2-propanol. Common name for this structure would correspond to thinking of this whole group here that I'm highlighting in yellow as a branch off of the oxygen atom right here. So if we think of all of this as a branch, the way that we would designate it as a branch based on our alkyl group names that were in our handout that we covered in video 310 is this is a tert-butyl group. And therefore, the alcohol common name for this would be T-butyl or tert-butyl space alcohol. So in order to understand and apply the common names of alcohols, you definitely need to be very current and up to date on the names of the alkyl branches, including propyl, ethyl, isopropyl, butyl, sec-butyl, tert-butyl, and isobutyl. You're expected to be able to draw out all of those and apply them toward determining the common names of alcohols. So now that we have reviewed this video, we should be able to determine the Iupac names for alcohol molecules, that is, including either alcohols that have chains with branches or alcohols that are rings that have branches come out of the ring. We should also, for very simple alcohol molecules, be able to assign the common name. And those simple alcohols are going to be ones where there is a common name that applies to the alkyl branch, such as isopropyl, tert-butyl, and those general branch terms that we learned back in video number 310.